Hello and welcome to the Blockchain Noise podcast. Today we'll be looking at the Bluzelle Whitepaper. To download the whitepaper and follow along, head to blockchainnoise.com/Bluzelle. That's blockchainnoise.com/Bluzelle. If you'd like to know when we release a new episode of our podcast and to have a say in what projects we cover in future episodes, you can join our Telegram community at blockchainnoise.com/Telegram. That's blockchainnoise.com/Telegram. Bluzelle, a decentralized database for the future. One. Introduction. Our vision is to make the internet a safer and more secure place for the data of people and businesses. 1.1. The problem. Blockchain technologies are propelling the next generation of the internet. Protocols like Ethereum are a platform for launching decentralized applications, DApps, that will change the way products and services are consumed. These DApps will exchange massive amounts of data that need to be stored and managed. The problem is blockchains like Ethereum are not designed for data storage and management. Doing so would take up too much space and take too much time. 1.2. The solution, Bluzelle. Just like decentralized services like Filecoin and Storj are needed for file storage and management, there is a need for data storage and management. Bluzelle is a decentralized, on-demand, scalable database service for DApps. Bluzelle fills a need and is complementary to the other components to make the decentralized internet complete. Without these decentralized components, the decentralized internet would not be able to run efficiently and scale to massive use. 2. History of Bluzelle. Seeing that blockchain can provide numerous benefits to the finance industry, Bluzelle was formed in July 2014. We created a technology stack that abstracts the complexities of managing blockchain applications. 2014, July, Neeraj Murarka formed Bluzelle in Vancouver, Canada. 2015, April, launches Canadian Ripple Gateway directly connected to Canadian banking debit network. 2016, February, sets up in Singapore. March, raises seed financing round from True Global Ventures. May, builds Ripple-based cross-border payments POC for global banking platform Temenos. September, builds Ethereum-based consumer mobile insurance application for global insurer AIA. December, named to the Global FinTech 100 by H2 Ventures. 2017 April, builds Ethereum-based KYC ledger for international banks consortium consisting of OCBC, HSBC, and MUFG. June, named Technology Pioneer 2017 by World Economic Forum. July, builds Ethereum-based insurance platform for a large Asian insurer. August, raises $1.5 million round from international VCs Global Brains, Japan, True Global Ventures, Europe, and LUN Partners, China. Working with enterprise customers revealed one critical challenge for widespread adoption of blockchain applications: the management of large amounts of data. This discovery led to the formation of the Bluzelle decentralized database service. 3. The current state of database services. It's estimated that in 5 years there will be over 20 billion connected devices that require the generation, management, storage, and retrieval of enormous amounts of data. Business leaders demand next-generation applications and new insights to drive more intelligent engagement and better decisions. To get there, enterprise architects need to design an agile technical architecture that can scale automatically with capabilities, such as databases, that are always available to support new initiatives. It takes enormous time, effort, and coordination to provision new databases today because of a lack of resources to meet the administration challenges of rolling out complex clustered systems. A quote from Forrester Research 2017 Market Overview, Database as a Service. To address this problem, emerged the cloud database and database as a service, DBaaS, market. According to Markets and Markets, this industry is expected to grow at a CAGR of 67.30% to $14.05 billion by 2019. There are 4 primary drivers of demand for DBaaS: consumer personalization apps, financial, dating, social media products, Internet of Things, IoT applications, everything is being connected, mobile apps, amount of data consumed is growing exponentially, line of business LOB, collaboration, business units share more info. With all these applications producing more and more data, past and present database management services are under-equipped to meet the need of businesses. There are problems centered around performance, reliability, and scalability. These can lead to problems of data breaches resulting in massive amounts of data theft. The systems of past and present will now evolve to the future, the Bluzelle decentralized on-demand database service. At this point in the paper, there's a diagram and a table illustrating the differences between past, present, and future database management. You can find these on page 10 of the original white paper. 4. Bluzelle features. Bluzelle is a decentralized database service for DApp developers. To ensure developers get the highest throughput in performance, reliability, and scalability, Bluzelle implements swarming technologies. A swarm is a large group of nodes, computers, that work together to store and manage data. Nodes in these swarms can go down and new nodes can come up, with minimal impact on the network. Overall, Bluzelle is a meta-swarm comprised of multiple swarms. 4.1. Performance. Bluzelle's unique and proprietary swarming techniques were designed for the highest performance. Bluzelle can reduce latency by retrieving data from the nearest nodes on the leaf swarm, and/or increase speed many-fold by retrieving data in parallel from the fastest nodes on the leaf swarm. This is like torrents and seeds. When data is requested, it is done in parallel where chunks, shards, are requested from all the different swarms that contain those shards, and these are all retrieved in parallel, resulting in desirable performance metrics. 4.2. Reliability. Using the concept of fog or swarm computing, Bluzelle follows a model where every unit of data is 100% replicated in a single leaf swarm amongst a swarm of swarms. So while the data is only in one swarm, that swarm's nodes are aplenty and are geographically dispersed, immune to localized outages caused by either natural or human-related events. 4.3. Scalability. Scalability is possible both horizontally or vertically. Bluzelle manages the various strategies and considerations around the use case of having to increase scale. Horizontal scaling is a cornerstone of the Bluzelle architecture, where every swarm is another unit of horizontal scaling at the metaswarm level. Within every leaf swarm, every node acts as yet another agent of horizontal scaling, at least at the swarm level. The following table outlines additional features of Bluzelle. Highest privacy. Bluzelle employs cryptography and sharding techniques to provide a privacy guarantee. High reliability. Bluzelle redundantly stores tiny pieces of data on nodes across the globe, eliminating any single point of failure. Enterprise scalability. Bluzelle algorithms store data in a unique, distributed, and intelligent manner that will provide enterprise-level scalability. Data immutability. Bluzelle leverages blockchain technology so that once data is stored to such a network, it is impossible to change that data. High-performance speeds. Bluzelle dynamically adjusts the number and location of nodes sharding the consumer's data to meet performance metrics. No intruders. Bluzelle's use of consensus is the only method by which updates to the network can be accepted as the truth. Low cost. Bluzelle operates few data centers and has little capital costs. Vast majority of computer resources are provided by participant producers. 5. How does Bluzelle work? Bluzelle takes blockchain principles and sharding and partitioning concepts to create an Airbnb-like marketplace for data storage and management. This is a crypto-economic network of powerful producers and consumers. 5.1. Consumer. The consumer is the one who consumes the Bluzelle database services. These are the developers we target. Consumers are spending Bluzelle tokens so they can store and retrieve data. Additionally, a user could get a credit of tokens if a producer failed to meet certain service levels. 5.2. Producer. The producer is the one who provides resources to the network in return for earning Bluzelle tokens, BLZ. Bluzelle producers will be required to put up a proportional stake of Bluzelle tokens in order to provide a guarantee on the service levels Bluzelle will provide. Bluzelle will encourage competition by producers to provide higher quality services, where those with higher service levels can charge more, but also have to put up a higher stake. Every participating consumer and producer of Bluzelle are initially required to independently create their own Ethereum account and take responsibility for securing and protecting their private key. The private key is used to secure access to their ETH and Bluzelle tokens and encrypt their data before it gets sent out over the Bluzelle network. 6. dApp uses cases for Bluzelle. 6.1. Predictions market. Decentralized predictions markets on Ethereum require the management and storage of massive amounts of data to work. These include 1. The questions being asked, 2. The different possible outcomes, 3. The predictions being made, and 4. The sourced information of the actual events. A decentralized database can grow and scale as per the product needs. Having fast and reliable access to data is important for the success of the predictions market to garner new customers and participation. Historical data stored on Bluzelle will add a new category of predictions that can reduce human speculation by using past events to make better predictions. 6.2. Currency exchange protocols. A key part of the currency exchange protocol is the presence of relayers, who enable makers and takers to connect via off-chain order books. The underlying order books must be fast, efficient, reliable, and easy to supply by the relayers. A pain point is relayers are responsible to store these order books each in their own way. By using a decentralized database like Bluzelle, currency exchange protocols can provide relayers with a standard, consistent, ubiquitous database that would be available with no effort. This reduction in friction maximizes the service level and quality, as the network would now still be powered by relayers. 6.3. Data streaming networks. Data streaming networks match up consumers of data points with producers of data points. For example, a car uses real-time traffic data from the data streaming network. The car collects real-time data while it moves. It is both paying for data it buys and earning from data it sells to the network. The data points need to be both readable and writable with high performance, availability, scalability, and reliability. Bluzelle is ideal to provide the precise infrastructure needed so that a data streaming network can store its data to meet these requirements. 7. Marketing strategy. 7.1. Target market. Bluzelle has 3 groups that it targets to become a mainstream product like Oracle systems. Bluzelle will start the first with the first group and then expand outwards. Early adopters, dApp developers. One of the fastest growing segments in the software industry. It involves software developers writing blockchain-based applications that take advantage of the other decentralized technologies that are complementary to Bluzelle. Early majority, small to mid-sized developers. Refers to developers that are not in dApps but building common web, mobile, hardware applications. These developers are writing games, productivity software, mobile applications, utility software, and many other software products. Late majority, enterprise software architects. The large enterprises who see how dApps and other developers use Bluzelle and then have the validation to also move their data storage needs to us. 7.2. Regional focus. With its offices in both Singapore and Vancouver, Bluzelle is in a unique position to grow in two of the biggest regions for dApps and the blockchain, US/Canada and Asia Pacific. From China to Korea to Japan to Southeast Asia, this region is home to a fast-growing startup blockchain community. These startups require efficient and low-cost services. Many parts of Southeast Asia are rapidly developing as major cities and high-growth economies. They are leapfrogging legacy client-server architecture systems to innovate adaptive and scalable solutions built for the future. Asia Pacific is anticipated to aggressively adopt cloud-based database and DBase services in the near future. This is basically due to the increasing focus by small, medium and large-scale enterprises for the purpose of improving efficiency and productivity via investment in technology. That's a quote from TMR Research Cloud Database and Database as a Service, DBaaS Market, 2017 to 2025. Bluzelle has an R&D center in Vancouver, Canada. Being in Western Canada/US gives Bluzelle a strategic position to offer its product to the growing blockchain and overall developer business in Seattle, Portland, San Francisco and Silicon Valley. Bluzelle's founders, advisors, investors have a history of working in Silicon Valley and have strong connections to build support in the world's biggest technology center. These regions are just a start. Bluzelle is a global product that meets the needs of developers everywhere. 7.3. The Bluzelle Developer Community. The first release of Bluzelle is planned for April 2018, and we have started building our developer community. Servicing software developers has less friction as they can be engaged online and are passionate about technologies that help them make better products quickly and easily. Early on, we will get feedback on the product and build the ecosystem enabling both the producers and consumers of Bluzelle. We will have an online community site, go to hackathons, host meetup events, and much more. As a tech company, Bluzelle's employees have an organic network of peers, friends, and acquaintances who are the target market. As mentioned in the prior section, Bluzelle will be doing various developer reach-outs to many of the biggest cities in Asia and US/Canada. 8. Bluzelle's ecosystem. The opportunity to get Bluzelle into the hands of consumers is tremendous. A key is to build a healthy ecosystem where Bluzelle is integrated to many technologies, making it easy for customers to find Bluzelle. 8.1. Developer marketplaces. Bluzelle aims to partner with leading software development ecosystems and establishing channel partnerships that share revenue. Notable examples would include Heroku, AWS Elastic Beanstalk, Red Hat OpenShift, Google App Engine, and Microsoft Azure. With such integrations, developers can quickly use Bluzelle's decentralized database just as effortlessly as they can use traditional cloud database offerings. Simply point and click. 8.2. Developer environments. Development environments, such as Android Studio, Apple Xcode, Microsoft Xamarin, and Visual Studio, Eclipse, IntelliJ, Unity 3D, PhoneGap, and Ionic are targeted for plugins and integrations so that dApp developers of both desktop and mobile apps can easily integrate Bluzelle whenever they have database needs for their games, enterprise applications, etc. 8.3. Blockchains. Blockchains play a large role in the Bluzelle ecosystem. Smart contract classes and instances are planned to be deployed directly not just to Ethereum, but other open blockchain protocols like Hyperledger to enable dApp smart contracts to use Bluzelle for storage needs. 8.4. Operating systems and browser tools. Operating system and browser tools further enhance the developer's ability to access data, whether it is from a GUI application running on their desktop or a browser plugin that enables them to quickly store and retrieve table data. 9. The Bluzelle token. Bluzelle is powered by two tokens: Ethereum ERC20 external token BLZ This externally tradable token bridges the Bluzelle native token, BNT, with Ethereum's own native ETH token. Bluzelle Network Token, BNT. An internal token to Bluzelle alone that enables the Bluzelle crypto economy, where consumers pay and producers earn. The need for an internal token is because ERC20 tokens are too slow and expensive for real-time database accounting. The BLZ ERC20 external token exists to represent on exchanges for customers to easily obtain to use the Bluzelle service. The BNT internal native token exists to enable high-speed, zero-cost and real-time database accounting. The BLZ and BNT tokens can be interchanged via the Bluzelle token gateway. For the public sale, people will be purchasing the BLZ tokens. When a new participant to the network wishes to use its services as a consumer, they will need to acquire BNT tokens. The standard method of doing so is as follows. 1. Buy BLZ tokens on a crypto exchange using ETH, BTC, or other forms the exchange allows. 2. Send BLZ tokens to the Bluzelle token gateway's smart contract via Ethereum. The gateway will issue new BNT tokens to the user's Bluzelle network wallet. 3. The user now has BNT tokens and is free to participate in the network as a consumer. When a producer wishes to withdraw their BNT tokens, they use the following steps. 1. Send the BNT tokens to the special Bluzelle gateway. 2. The gateway converts the BNT tokens at a 1-to-1 ratio to BLZ tokens, and sends these BLZ tokens to the producer's registered Ethereum wallet. The producer now has the BLZ tokens, and is free to transact with them on the Ethereum network. 10. Revenue model. The BLZ to BNT gateway proposes a microtransaction fee for every conversion going through the gateway in either direction. The fee is charged in BLZ tokens and is sent to a special Ethereum wallet owned by Bluzelle. The model is set up so the entire ecosystem remains completely decentralized while still providing a revenue for Bluzelle to improve and innovate the network and its associated services. Following are two typical scenarios. A user needs BNT tokens to use the service. 1. The user sends 100 BLZ tokens to the BLZ smart contract. 2. 0.1 BLZ is subtracted from the total of 100 BLZ and is sent to the Bluzelle Ethereum wallet as a non-refundable fee. The remaining 99.9 BLZ is converted to BNT and credited to the user's BNT Bluzelle native wallet. A user wishes to convert BNT to BLZ. The user sends BNT tokens to the BNT gateway. 2. The BNT tokens are converted at a BLZ 1-to-1 rate, resulting in a conversion amount of 100 BLZ. 0.1 BLZ is subtracted from the total of 100 BLZ and is sent to the Bluzelle Ethereum wallet as a non-refundable fee. 3. The remaining 99 BLZ is released out of custody by the Ethereum smart contract and sent to the correct participant's Ethereum wallet. Absolute prices are calculated dynamically and are not 100% deterministic. Maximums are baked into Bluzelle, where the network adjusts the number of swarms and distribution of nodes as prices start to approach the maximums, getting increasingly aggressive with network adjustments as the maximums draw nearer, until expected average prices start to trend again. 11. Technology overview. This section provides an overview of Bluzelle's technology architecture. For a more in-depth reading with more details, refer to the technology paper. 11.1 Database 101 CRUD API. CRUD stands for Create, Read, Update, and Delete, for the four basic functions pertaining to databases and permanent storage. CRUD covers the functionality of relational databases, where each of Create, Read, Update, and Delete can be mapped to corresponding SQL and HTTP methods. A password of the user's own choosing is also required, and it is up to the user to protect this password and keep it available for later. All the data stored in key value pairs are encrypted, with the password being used as the initialization vector in AES-256 symmetric key encryption. This password is only ever used locally and never travels on the network in any way, shape or form. 11.2. Sharding. SHARD stands for System for Highly Available Replicated Data. Large databases often are hard to work with due to the size and memory constraints they come with. By partitioning the database along logical lines, the data becomes much easier to work with. A logical shard is the smallest unit in Bluzelle and contains individual units of data that all share the same partition key. A partition key is the unique identifier that allows the shard to be accessed for the retrieval of information. In Bluzelle, partition keys allow the DApp to store and retrieve data from the correctly identified leaf swarm efficiently. In Bluzelle, groups of logical shards are stored on leaf swarms, and it's the amalgamation of these leaf swarms that make up the entirety of the Bluzelle database. 11.3. Jump Consistent Hashing. Jump Consistent Hashing, JCH, was first described in a white paper by John Lamping and Eric Veach at Google. It is an elegant algorithm that only takes about 5 lines of code in a language like C++. JCH does not have a state machine and therefore requires no storage. It is an algorithm without lookups in memory and is therefore much faster. Bluzelle uses JCH to map from the key in key value pairs in a NoSQL table to the ID of the swarm that the key is replicated in. Once that ID is found, Bluzelle uses Kademlia hashing to find the means to reach that swarm, even if that specific swarm is not running. 11.4. Kademlia hashing. Kademlia is an advanced form of a typical peer-to-peer distributed hash table, which has been structured in a way to make particular use of the special symmetric and geometric properties of the bitwise XOR function. Bluzelle uses Kademlia hashing to efficiently enable nodes to know about every other swarm on the network. Using Kademlia's own form of finger tables, each node in the network only needs to know information about how to reach O log n other leaf swarms, where n is the total number of leaf swarms on the network. This means that irrespective of how large the network ever becomes, every node can reach every other leaf swarm within O log n tries, by only storing O log n data. As a result, Bluzelle is able to handle exponential growth. 11.5. Partial replication. Partial replication means that not every node in the network has a copy of the data. Only the nodes within the leaf swarm delegated to that data replicate it. This is one of the key differences between Bluzelle and a traditional blockchain. Blockchains are inherently slow and do not scale well, as every set of transactional blocks is 100% replicated everywhere, putting severe vertical scaling limitations on the network. Bluzelle by design only stores the data amongst a strategic subset of the nodes, statistically providing a guarantee that the data is always available and still achieving the benefits of boundless horizontal scaling. Partial replication exists because only one swarm amongst all the swarms in the network replicates a given piece of data. An interesting incumbent technology that can be compared to this is the Content Delivery Network, CDN. 11.6. Load balancing. A benefit of having a logical shard stored on multiple physical nodes is speed. By having the same data accessible through different hardware resources at various geographical locations, the system may load balance queries to retrieve data from nearby nodes that are least taxed at any given moment in time. This permits Bluzelle to dynamically perform queries and retrieve data in the most efficient way possible, maximizing the use of the shared resources spanning across multiple nodes. 11.7. Redundancy. As replicated data is stored across different nodes with unique infrastructure, there is a severely reduced causation between single node failure and loss of the shard. This method of mirroring serves to secure the availability of data in an efficient manner by ensuring any single point of failure is inconsequential. 11.8. Consensus. Bluzelle deals with consensus differently from blockchains, doing away with any concept of a network-wide universal state. There is no need for a single state for the whole network, so Bluzelle applies the consensus model on a swarming level, ensuring that leaf swarms of nodes storing data shards are each reaching localized consensus using our customized forms of consensus and proof algorithms. A swarm with consensus appears to clients interacting with that swarm, or other swarms interacting with the swarm, as a single atomic indivisible unit that stores a set of data reliably. Any node in that leaf swarm can accurately service requests pertaining to that data. 11.9. Karma. Every producer on Bluzelle is entitled to run one or more nodes on the network as farming nodes. Each such producer will use their Ethereum address as the key that identifies them. This identifier is unique to that farmer and is tied one-to-one with their Ethereum address. The producer also has a karma index, which is a score that dictates how well behaved the producer is. The karmic index can go up and down depending on the producer's activities and decisions, intentional or not, autonomous or not, and spans all the nodes the producer operates. If one such node misbehaves, the karmic index typically drops, and this applies to all the producer's nodes. Furthermore, the farmer is required to put up a stake in BNT tokens that is proportional to the number of nodes and inversely proportional to the karmic index. 11.10. Sybil attacks. Some blockchain networks, like Bitcoin, allow anyone to add their node to their network. That brings the concern that a malicious organization could potentially add so many nodes that they disproportionately control the network and leading to hijacking the network. This is referred to as a Sybil attack. Bitcoin and Ethereum obviate Sybil attacks by making them prohibitively expensive via proof of work. Bluzelle employs several methods to prevent Sybil attacks, so that when a bad actor is caught, they can be blacklisted and economically penalized, leading to complete removal from the network. These anti-Sybil attack methods are: producers are required to put up a BNT stake to participate in the network. This stake serves as a requirement for participation and as a strong economic deterrent from bad behavior. The Kademlia distributed hash table is used, as it relies on message redundancy and the XOR distance function. Neighbours are selected and messages are redundantly sent to multiple neighbours of the intended node for anti-Sybil verification purposes. Nodes that mislead the swarm location effort will be systematically tracked down and caught. A request to a swarm for CRUD functionality is done with redundancy, when multiple nodes in the same swarm all perform the request. Given the node-to-swarm membership rules for Bluzelle, it is statistically unlikely that multiple such nodes chosen to perform a given transaction are colluding bad actors that deliver bad yet consistent data. Swarm membership is determined by the network and cannot be chosen by nodes. This means that a would-be Sybil attacker who attempts to join the network with N nodes, or masquerading with the identity of N nodes, will not be able to gain a critical mass of memberships into any single swarm. Nodes can be posed as a challenge request to participate in a proof of storage test. This test is performed in cooperation with the consumer on either a random network-initiated basis or by the consumer directly, and forces the targeted node to prove that they have the correct data. 11.11. Byzantine General's fault. One way to protect against Byzantine faults is to have a default understanding of what to do if there's no information. In Bluzelle, if misleading or corrupted or inconsistent information is detected, the default is to do nothing. Thanks to the aforementioned redundancy in CRUD requests made to a swarm, inconsistency is caught whether intentional or not. In any case, Bluzelle nodes are instructed to ignore the transaction and do nothing. Only authenticated transactions with proper credentials and checksums are accepted and transacted upon. By this way, Bluzelle is Byzantine fault tolerant by design. 12. The company. Structure, team, investors, advisors. Bluzelle Platform Pte Limited is a Singapore company. Singapore is chosen for its ecosystem of fostering blockchain innovations and regulations that support the growth of well-managed businesses. 12.1. The team. Bluzelle is a team of 10 and growing, with mainly top engineers with backgrounds in computer science, AI, cognitive science, blockchain, security, networking, and more. Some members are Pavel Baines, CEO, Neeraj Maraka, CTO, Nitin Khanna, Senior Developer, Scott Birch, Senior Developer, Mehdi Kolachi, Senior Developer, Yingyao Zi, Product Associate. Pavel Baines, CEO, Co-founder. Pavel has over 15 years' experience in operational management, digital technology, and finance. An NCAA Honor Roll student athlete from UCLA. Pavel also was the co-founder of StoryPanda, a digital book platform that published critically acclaimed titles by DreamWorks, Warner Brothers, Peanuts, and more. Pavel was in GM and CFO roles for video game studios, including looking after 7 Disney studios across 4 continents and 350 people and $150 million budgets. Neeraj Maraka, CTO co-founder. Neeraj is an engineer and computer systems architect with over 20 years' experience. He has worked for Google, IBM, Hewlett-Packard, Lufthansa, Thales Avionics. Projects include locking down of modified Android OS for retail markets, multicast UDP satellite-based systems, design and development of secure and FFA-approved systems for Airbus and Boeing. Neeraj was the 4th employee of acquired blockchain startup ZeroBlock. 12.2. Early investors. Bluzelle raised a round of financing from venture capital firms to kickstart development of the database service, accelerate staffing, and provide capital needed for the token sale. Global Brain, True Global Ventures, LUN Partners, Kinetic Capital. 12.3. Advisors. Bluzelle has put together a specialized unit of advisors to guide the growth of the business. Each person is a technology heavyweight contributing to companies like Facebook, PayPal, LinkedIn, Ethereum, and more. These include the following. Jill Penchina, super angel known for investing in Ripple, Civic, LinkedIn, and more. Brian Fox, CTO Orchid, creator of Bash, open source advocate. Prashant Malik, ex-Facebook engineer, creator of Cassandra DB. Alex Leverington, core Ethereum developer, founder of Metagrid, crypto tech expert. 12.4. Corporate governance, compliance, legal. Bluzelle believes in maintaining high standards for operating a transparent business. We have created a group of top professional firms in legal and accounting to ensure these standards are met. Orion W., legal counsel for Singapore, Brian Cave, legal counsel for Hong Kong and USA. We have engaged one of the Big 4 professional service firms to assist us on accounting, tax and governance advisory services. 13. Token sale. Bluzelle will be executing a token sale to raise funds for development and commercialization of its decentralized database service. The maximum amount we will accept is a value of $19.5 million. The only accepted currency will be ETH. Exact pricing of ETH to BLZ will be determined at a later date prior to the official token sale. 13.1. Token allocation. Token sale, 33%. BLZ will be offered for sale so that consumers and producers can become part of the ecosystem early and have tokens needed to be used for Bluzelle. Retained by Bluzelle, 27%. The retained tokens can be used in additional offerings to further development and staff incentives. Developer fund, 10%. Used to incentivize, reward, and attract outside developers to build projects, integrations, partnerships, hackathons, and community involvement. Growing an ecosystem is important. Founding team, 15%. Bluzelle's founders have been working on the business for over 3 years. Allocation of their BLZ tokens will vest over 3 years. Early backers, equity investors and advisors, 15%. Bluzelle has been fortunate to have early investors and advisors to help with the development of the technology. Part of the equity investments have been converted into tokens. 13.2. Use of funds. Research and product development, 55%. Used to continuously develop the product, grow the team globally. Network costs, 10%. Initial capital needed to seed the network with nodes and kickstart the decentralized service. Sales and marketing, 20%. Grassroots marketing to start and expand to conferences, sponsorships, advertising. Operations, 10%. General overhead and administrative costs for running the business on a global scale. Legal, accounting, compliance, 5%. Important to Bluzelle to maintain high standards for its operations and provide transparency. 14. Roadmap. We break down the development of Bluzelle into 4-month releases, each named after a physicist. 2017, December, Lovelace. Single swarm NoSQL key value pair raft consensus storage facility, driven by a minimum stake of BLZ ERC20 tokens on the Ethereum blockchain. 2018, April, Curie. NoSQL key value pairs, Bluzelle harvesting agent, leaf swarms, consensus, horizontal partitioning, consistent hashing, CRUD API, Bluzelle tokenization, ERC20 token gateway, versioning and backup restore, dynasty keys. August, Kepler. PaaS integrations, IDE plugins and integrations, blockchain smart contracts, desktop and browser and mobile apps for interactive access, import-export from legacy databases, node scoring and health metrics. December, Einstein. NoSQL documents, NoSQL document collections, NoSQL document collection indices, NoSQL document collection partitions, global CRUD operations, batch CRUD operations. 2019, April, Leibniz. Proof of storage Merkle challenges and rewards, proof of stake requirement for farmers, variable CRUD request pricing, edge caching of data close to requests, request parallelism and hotspot support, Spartacus attack tolerance. August, Archimedes. Vertical partitioning, 2D partitioning, variable cost data expires, Sybil attack tolerance, deletion reversibility, proof of redundancy via erasure coding. December, Turing. Column stores, S/Kademlia improvements, honest Geppetto attack tolerance, third-party arbitration against cheating owners attacks, reverse HTTP tunneling, tunnel eclipse attack tolerance, multi-party encryption, complex binary blob storage support. At the end of the white paper is included a risk disclosure. This overviews company risks, including company failure, management failures, no governance rights, business model risks, etc. Product risks, including delay, inability to use BLZ, failure to develop and support the service, etc. And technology risks, core technology risks, integration risks, smart contract risks, etc. There are further regulatory risks, market risks, and participation risks, all detailed at the end of the white paper. If you're interested, you can find the white paper on our website at blockchainnoise.com/Bluzelle. There ends the Bluzelle white paper. Thank you so much for tuning in. If you've enjoyed this episode, make sure you join our Telegram community so you can have your say in what projects we cover in future episodes. To do that, you can head over to blockchainnoise.com/Telegram. That's blockchainnoise.com/Telegram. See you next time.